All right, in this video, I'm going to briefly go over the classwork that we had for multiplying monomials. We're going to do a little practice with that. I'm going to start with classwork, and then I'm going to finish up with an example or two from the IXL. I think you don't need too many different examples for it because it is a little self-explanatory once you understand how to do the classwork. All right, so let's get to it. Here we see number one says, or the directions for this say to simplify the following, showing all work. Make sure you show the work. That's an important part. That's how I know that you know how to do it. When we are doing this, we learn kind of two methods that really do the same thing. You just may prefer one method over another. The method I'm going to start with is expansion, exponent expansion. We have this 3 cubed times this 3 to the 4. So this 3 cubed, and we're going to underline these in different colors to help bring home the point of what I'm doing, times the 3 to the 4th. So this 3 cubed is 3 times 3 times 3. And then we're going to multiply everything times 3 to the 4th, which is going to be 3 times 3 times 3 times 3. Okay. And I believe I explained it in the video and in class quite a few times. The way we do these exponents is literally we multiply whatever the base is, however many times that exponent says, and we write it out. So this 3 cubed is written like this. This 3 to the 4th is written like this. Another way to write it, once we have it, is just count 1, 2, 3, 4, 5, 6, 7. It's going to be all equal to 3 to the 7th. All right. Now, if you give me 3 to the 7th as an answer, I'll accept that. Or if you want to give the actual number value of 3 to the 7th, you can type that in to Desmos, and it will give you that. 3 to the 7th is going to be, see if I can do it on this calculator. No, I can't. The way you're going to do it in Desmos, and this is a great opportunity just to show you all how it works. Pull up Desmos. And the function we're going to look for, or you can use, is that caret key. 3, we type in 3, and then hit Shift 6. When you hit Shift and 6 at the same time, it'll raise your cursor up, and you can type in your exponent. And when you type in your exponent, it spits out the number for you there. 2187 is 3 to the 7th. So if you give me 3 to the 7th or 2187, I'll accept either one of those as the correct answer. For the most part, though, I want this one going forward because these are just kind of how to multiply monomials. If we look at a different example, like this x to the 8th times this x to the 5th. All right, let's do my colors for this one as well. The other way we learned is when we're multiplying these things, the x to the 8th and then x to the 5th. The other way we learn is to just add those things together. We end up doing an 8 plus the 5, and that gives us 8, 9, 10, 11, 12, 13, 13. And then we take that 13 and we put that as our new exponent. And so we end up with x to the 13th, because x is still the base of both of these. I just didn't write it out. X to the 5th, and then plus x to the 5, we add those exponents and we end up with x to the 13th. All right, that's the other method we learned in the notes. So those are the two different methods we learned for problems like that, just so you guys have a little bit of an idea. And then finally, I'm going to do something like maybe number 8. Number 8 is one that looks a little tricky. It's not too bad though. Number 8 says x to the 4th times y to the 5th, all cubed. And the way we do that, let's use this color, is x to the 4th is x times x times x times x. And I'm not writing the dot between because that's going to take a while longer if I do that. Times y times y times y times y times y. That's one of these. All times, I'll do it 3 different colors. X times x times x times x times y times y times y times y times y. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, just want to make sure I'm writing out the right number. And then once again, all times finally x times x times x times x times y times y times y times y. All right, this is expansion, power expansion. This is what we do. One of the methods we can use to solve these things. I've written out my x to the fourth, y to the fifth, 3 different times. And then what we end up doing is just counting all my x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different x's. So I end up with x to the 12th. And then count my y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oops, forgot a y. 15. So that should be 5 y's right there. X to the 12th, y to the 15th. All right. That's how we do that with power expansion. The other method that we use, or we can use when doing these, which just makes it a little bit quicker because you don't have to write it all out, would be to take your 4. It would be 3 times the 4. And that will be your exponent for your x. So 3 times 4 gives you 12. So you get x to the 12th. And then we do the same thing with the y. For the y, actually I use a different color for y. For the y, that would be this 5 times this 3. Okay. And so we get y. 5 times 3 is 15. 15. The reason we do it differently is because it can be a little bit confusing if you don't know when to add and when to multiply. You only multiply the exponents if it's in a parentheses with an exponent on the outside. You add them when you're multiplying two of the same bases that have different exponents is when you're going to add them. All right. That's why we do the expansion method, because if you write it out every time, you just count the total number and you can't mess it up. So that's all I'm going to do. Those 3 different problems for the classwork. Now for the IXL, it's for the most part the same thing, except these will give you numbers. This says 12 y to the 8th all squared. First thing you need to do is figure out what 12 squared is. You can type that into Desmos and it'll give you 144. And then y to the 8th, you write that out 2 times. Y to the 8th, y times y 8 times. And that'll give you y to the 16. All right. And that's going to be how you do these. That same method. Okay. So that should help you as you all go through if you've gotten stuck or something like that. If you need more assistance, come back to the Zoom and ask for help there, and we will get you squared away. Okay.